props. This is very important. Okay, so let's check it out. You need to define the density. And then this is the basic PVT for water, reference pressure, formation volume factor, compressibility of water, water viscosity, and viscosity. And then this is the PVT data table for the oil as usual. You have GOR, the pressure, formation volume factor, and PVT. Okay, and then this is typical. And then PVDG, you have pressure there, and then formation volume factor, and then you have gas viscosity. Okay, and then rock for, as usual, rock compressibility. Okay, so the reference pressure 4,000, and you have the rock compressibility at that pressure. And then PMISC. This keyword defines tables that model the transition between immiscible and miscible displacement as a function of, in this case, oil pressure. Okay, so this is the pressure that we have. The local pressure of oil phase, 3,000, 4,000. Okay, and this is the miscibility, which will vary between 0 and 1. Okay, the miscibility equal to 0 corresponds to immiscible displacement, and 1 refers to miscible displacement. So we are injecting, or we are targeting to more into the miscible injection, miscible displacement, which is good for our enhanced oil recovery. Okay, and then TL mix par. So let's go down. Okay, this keyword is also important. TL mix par is, this keyword defines the Todd Longstaff mixing parameter. So it's about mixing parameter. You can see here, Todd Longstaff, that the technique that we use to define the mixing parameter. Okay, so you have the first column there, the Todd Longstaff mixing parameter for the viscosity correlation calculation, and this is the parameter Todd Longstaff. That's the technique of this calculation that we will use. The mixing parameter 0.5 for the density calculation. So this one is for viscosity calculation, that one is for density. Okay, so yeah, we are not very familiar with all of this. So now we learn together that performing enhanced oil recovery in simulation is not that straightforward. We need to have more keywords. We need to be familiar with a lot of new keywords here and there. And then what else? S density. This keyword specifies the surface density of miscible injection gas for the miscible displacement model. Okay, surface density of the miscible injection gas. And then PVDS. Okay, pressure, formation volume factor, and then viscosity. Okay, PVDS. Another setting for us, PVDS. And then, okay, this is a relative permeability. Let me minimize. Okay. This is for water saturation and relative permeability of water. And this is the capillary pressure for oil water system. You see here we have 1, 2, 3, and 4 regions. And we will check the regioning later. And this is for the gas saturation, and then relative permeability of gas, and then capillary pressure for oil gas system. Region 2, region 3, region 4. Data for each region will be closed with this slash. And then this one for the oil. 1, 2, 3, and 4. Okay, so this one is another relative permeability dataset. We'll check it later. Okay, so another weird keyword, SSFN. So this is phase fraction, gel relative permeability multiplier, and then solvent relative permeability multiplier. So this is phase fraction, so the fraction for the solvent. This will be relative permeability multiplier for gas, and then this is the relative permeability multiplier for the solvent. Okay, so that's it. And then we have also something called MISC. Okay, this is for the solvent versus fraction miscibility. Okay, sorry, solvent fraction, and then this one will be the miscibility. And then this one is SORW MISC. This is the water saturation, and this is the miscible residual oil saturation. So there will be difference between immiscible injection and the miscible injection with regard to the residual oil saturation. Of course, the residual oil saturation will be smaller in miscible injection, miscible displacement. In this case, it's quite extreme. The miscible residual oil saturation is 0. So it's like you can push all the oil, okay, out of the pores, which is really not, it's not real, by the way. But for the sake of simulation, we can take it. And this is water saturation and miscible critical gas saturation. So as you can see, this is very important. The property section is very, very important for enhanced oil recovery simulation or, solvent injection simulation. Okay. And then we check we check the fluid properties here. So you see here we have 4 regions, right? As per the dataset. Okay. So here you go. This one, SWFN, okay, 0.2207, 0.3, 0.0074, okay? And then this is the RP for hydrocarbon, the same. Okay, and that's actually, if you can check it, this one, SOF3. Okay, 0.38, okay, 0.00432. Okay, and let's check. They are basically the same, right? Okay, and then we also have RP oil for 3-phase. Okay, and then this is for the gas, PVT for water, PVTW, okay, PVTO. This is PVT for the gas, and then rock compressibility, RSVD, okay, RS versus depth, RS, of course, the GOR, gas oil saturation, gas oil ratio, density, okay. We define density for the 3 phases, oil, water, and gas on the data set previously we checked, which is here. Density, right, for oil, water, and gas. Okay, again, relative permeability for oil, water system, gas, oil system, and this is for the equilibrium. Later we check it in the solution section.